La or Singhiasla Dalangwadakon. Good evening, everyone. Hawa for joining us. Katkis Hanidi Kigaga, Raven Rylan Yatsaidaga Hanidi Kigaga. So I just said good evening. My name is Katkis. Raven Rylan is my English name. I am the projects and partnerships lead here at Swiilawiid Sustainability Society. And we are co-hosting this event with the Gwaay Renewable Energy Cooperative. This is one of two webinars that we will be doing. We have one next week as well on cooperatives, and we're happy to have three guests here from Yahda Energy and UVic Primed to talk about Taajuuway, wind feasibility and local research project updates, and also an update on TYE, on Yahda Energy, on what they're doing. So we'll do a quick introduction of Swiilawiid to start, and then we'll do a quick presentation by Yahda Energy, and then a 30-minute presentation by UVic Primed with a question and answer period at the end. We are recording this on Zoom, so we can be able to make this available on our website at Swiilawiid at a later date, so people can be able to hear all the work that's going on in the community. So to introduce Swiilawiid, we are committed to the shift to renewable power on Gwaay. This is important to our well-being and independence at a time of climate crisis, and it's our responsibility to our children and grandchildren. Swiilawiid is a neutral, non-profit organization that amplifies all local renewable energy stories and successes. We uplift champions, share information about projects and technologies that will help us achieve a clean energy future. And we're committed to building resources and creating spaces to build this shared future together. And before I introduce our guests, as one of our topics is wind energy, I wanted to highlight a resource that Swiilawiid published in 2022, which you can find on our website, called Renewable Energy Options for Gwaay. Within this resource, we highlight the advantages and considerations of each renewable energy option, like wind. So like advantages of wind power is that it's well-developed, popular, and readily available technology that continues to become more efficient. Though wind is intermittent energy source, Gwaay has an abundance of wind, particularly on the north and east coast, as we saw the past few days ago. On the right side, wind energy can operate for 25 to 30 years. And then considerations for wind is for residential use, wind energy is best suited for remote areas because it requires unobstructed exposure and clear and consistent winds. Large onshore wind farms can take up a lot of land, which can lead to loss of habitat and biodiversity. Wind farms built in bird migration routes, important bird areas, and bat habitat have contributed to bird and bat deaths, but this can also be avoided with proper site screening, smaller scale projects, wildlife assessments, field studies, and post-construction studies. Offshore wind farms need to consider the impacts on the ocean due to construction, operation, and maintenance, and taking into account increasingly fragile ocean systems. And so that's just one renewable energy source that could be used. And so feel free to check out that energy options for Gwaay. So how this webinar got started is UVic Primed met with Swiilawiid to discuss some of the work that they've been doing with CHN Marine Planning and Yahda Energy. And they wanted to bring some information to the community, and we were happy to do so by hosting this webinar. We first met UVic Primed at our Renewable Energy Symposium in March of this year, and we're very happy to have them back and bringing Yahda in as well. And so our first guest is Yahda Brennan to provide a TYE update before we talk about more of the wind study and local research projects. So go ahead, Sean.
Good evening, everybody. My name is Sean Brennan, the implementation manager for Yahda Energy. And so are we just doing introductions, or am I jumping right into the presentation?
Feel free to do your presentation, and then we can focus mainly on the wind.
Sounds good. So yeah, as we've been sort of pretty public and prominent in the past year and a half, Yahda Energy, or TYE, is a tripartite between Skidegate Band Council, Old Massive Village Council, and the Council of Haida Nation. And so our first major project is the Solar North project in the north. So I might as well just jump right into the presentation here. And so yeah, since the last time we had an update in the spring, the Solar North project has really taken off. We sort of just updated on the geotechnical studies and our piling testing and that sort of thing to make sure that the geological site was suitable for a solar farm. And so it all passed. Everything went by really well, and we began construction in the spring of this year. We hired a 100% Haida crew to do the training. A lot of the installation work was done by a group called Solvist, and another our consulting project manager was a group called Hedgehog Technologies. And so after we did the pilings, all the rackings went in, everything went in ahead of schedule. And a lot of the crew was like really impressed with how well and how fast our crews were putting all this stuff together. So we went through racking installation, panel installation, and construction wrapped up around July of this year. And so yeah, this is on track to being displacing 660,000 liters of diesel per year, 1,780 carbon tons annually displaced by the solar farm. And it's really just like a really big place of pride, I think, for our community so far. This is the first project, the first step in our renewable energy sort of journey and the vision of getting off of diesel here on Haida Gwaay. And so our farm, the construction phase was completed in July, as I mentioned, and this was at the end of July. It was visible on Google Earth like instantly. And so right now our next steps are for we're just awaiting the connection materials. There's still a backlog from when we ordered it in the springtime of about a year for transformers and inverters and that sort of thing. So in the spring of 2024, we should be receiving the rest of our materials, and connection should continue. And so yeah, this is the day after our last big hurricane there, and our solar panels all held up really well. They're far enough away that none of the debris or anything like that even got really close. And this picture was taken at about 9 in the morning on Tuesday. And as you can see, it's like late November, still early in the morning, and the solar panels aren't even like in the shade. I'm pretty happy about that. I was like sort of curious about how that was going to turn out. As for our next sort of projects that we have on the go, Yahda Energy secured funding through the BC Ministry of Municipal Affairs. The Community Infrastructure Fund fully funded the Solar South project, and so we've begun feasibility work on that as well. Part of the Solar North project includes a battery that's being designed and built by BC Hydro. And so right now what we're looking at doing is the feasibility of a battery on the south end as well to increase efficiencies on the diesel generators. And the main thing would be to accommodate more renewable energy projects in both the north and south end. Right now we're going through what that feasibility looks like with Hatch. Here's the crew from BC Hydro and Hatch, who are doing the feasibility work on that. Sort of like where we're going to be putting that what that's going to look like, what the capacity is going to look like of that next solar farm, and what the site selection would be. And so far we have got support from Transport Canada, but saying that they have initiatives to green up their airport as well. So they offered for us to use some of their Transport Canada land near Sandspit there, or in Sandspit proper, and we're just sort of exploring what that's going to look like, where the best sort of spot's going to be going, or would be for another solar farm down in the south. But one of the big things that we recognize here is that solar is not really going to be just like the single answer for the renewable energy vision that we have on Haida Gwaii of getting off of diesel. And so what we recognize is that we need to talk to people about what the desires and wants of the community would be for the next type of renewable energy project. Keeping in mind the parameters that like BC Hydro have, where we're talking about like some of the stuff that we proposed from the beginning were things like tidal and biomass and other different projects that were just sort of like a bunch of different ideas that were proposed and had some feasibility studies that were done in the past. And so what it sort of came down to was whether or not BC Hydro found that energy to be proven technology. And so solar just was a low-hanging fruit, right? Like we knew that BC Hydro was going to accept that technology on their grid. The price of solar has come down to about a third of what it was 10 years ago, and it just seemed like a really easy idea. And so that brings us to where we are now, where we've secured funding for Community Energy Plan 2.0. And so what we had done in 2019 was a community energy plan that ended up looking like a community energy profile, which talked about the different types of renewable energy technologies that are available on Haida Gwaii and what would be best suited for, what criteria and selection criteria that we had for those different energy systems. What that really looked at mainly was the different types of technology that was available, or the renewable energy types that could be like implemented on Haida Gwaii, but it didn't really take into account a lot of the community opinions and reflect that sort of true engagement of the community that we needed for that social license that we all know and is like required for doing business on Haida Gwaii, let's say. So one of the things that we wanted to do is to really go out and talk to the community about what that energy vision is going to look like between now and 2030, 2035, 2050, long-term sort of thinking, and what type of renewable energy technologies that we can start to explore next. And so what we've been working on is talking with BC Hydro about 2030 planning and long-term resource modeling. And that's where we've really begun to look at or work with groups like Primed, and I'll let them introduce themselves and talk about the type of studies that they've been doing and that sort of thing. But that's really where this conversation really started from, and why we wanted to bring it to the public and talk to you guys about it. Yeah, I just wanted to give that sort of primer and let people know that that's like why we're hosting this session tonight. And without any kind of further ado, I guess I'll hand it over to the Prime team to take it over.
Taajuuwée, that's really great update on that. You've been doing some great work, and it's I like the pictures of everyone with their great faces and smiling. And I just wanted to let everyone know that you can turn on your videos, make it a little bit more friendlier to see everyone in person, since we can't be in person. So feel free to do that if you want. And so yes, so feel free to go ahead. UVic primed, Riley and Jackie. Excited to learn more about what you are doing with Toyota and other research projects you've been up to.
Awesome. Well, thank you so much, Raven and Valine and Swiilawiid for having us here tonight, Sean as well. So I'm Riley Richardson. I'm a project manager and engagement lead at Primed, and tonight I'm speaking to you from the traditional territories of the Musqueam, Squamish, and Tsleil-Waututh nations. And tonight we will get to wind, but we're going to start with a brief overview of kind of who and what Primed is. An intro into marine renewable energy, and then start to get into some of the research we've been doing up on Haida Gwaii, and then some of the planned wind assessment work we have for next spring. So I'll pass it over to Jackie.
My name is Jackie Vanderput. I am a research scientist and field coordinator at Primed, and I'm speaking to you guys from the traditional territory of the Malahat Nation. Yes, thank you again, Raven and Sean, for all having us. It's been really awesome thus far. So yes, as Riley has mentioned, we both work for Primed. Primed is a small research group under the Mechanical Engineering Department at the University of Victoria. We're just a small little group of 9 people. In total, there's 6 engineers, 2 of which are co-directors. We have 1 software developer. We have Riley, who's a geographer, and myself, who's actually a geologist. So what does Primed do? Well, our main objective is really just to accelerate the development and adoption of marine renewable energy technology. And we do this by working with and between academia, industry, governments, and end users, such as communities like yourselves, to be able to identify marine renewables that are available and quantify it, and really look to see if it's feasible, whether we can do it or not. And so all of this is really done through field measurements that produce high resolution wave and tidal data. We also do grid modeling, and then we can do an integration analysis as well to see if marine renewables can be incorporated to communities' electrical grid. So what is marine renewable energy? Well, really it encompasses all renewable energy that is derived from the ocean. So whether that is indirectly from solar radiation causing wind and waves, or directly from gravitational forces causing tides. So the graph here that you guys see on your left, that's just the global annual theoretical resource. That theoretical resource is massive. It is about 3 times of the global electricity consumption in 2019. However, with that said, not all marine renewable energy is available on every coast. So for example, here in BC, thermal energy is actually not possible because it does require a change in water temperature of about 20 degrees Celsius. And being the mild climate that we are, we just don't have that. So today, Riley and I's presentation will mostly focus on the marine renewables that we do have and that we can have on Haida Gwaii, which is mostly just wind, wave, and tidal.
Yeah, so as you can see, other than offshore wind, which is a really well-established design thanks to decades of development onshore, there's still many different designs for wave and tidal energy. So point absorbers such as CalWave and AWS Energy, these devices move with waves relative to the seafloor and then convert that kinetic energy of wave motion into electricity. You have other designs such as wave swell. This is what's known as an oscillating water column. So it essentially creates an artificial blowhole. And as waves pass through, air is moved to and from atmosphere, and that drives a bidirectional turbine. For tidal energy, there's 2 primary types. The first is tidal barrage. So it's very similar to a hydroelectric dam. You allow water to fill a reservoir as the tide rises. This is usually a blocked off estuary. You store that water within the reservoir, and then as it recedes, you release that water at low tide. The other type is tidal stream. So these devices capture the kinetic energy of flowing water, and there's a range of designs. They can be floating, like Yorebrook's paddle wheel up in Haida Gwaii, or they can be submerged, like Monesto's tidal kite, or Simic Atlantis's horizontal axis turbine. So one of the greatest benefits of marine energy is its predictability. So this is especially true for tidal. It can be predicted days, weeks, and years in advance. And then wave and wind have peak electricity or peak energy availability during winter months. And this is really great because it aligns with peak electricity demand in BC. And then when you look at water being 800 times denser than air, wave and tidal benefit from higher power density. So this means less area is required compared to other renewables to produce the same amount of power. So a good example, because these devices look very similar, they can both produce up to 1.5 megawatts of power, but there's a huge difference in the rotor diameter for each, and 18 times more area required for a wind turbine to produce the same amount of energy as this tidal turbine. Aside from tidal barrage, which when you're damming off an estuary, that really impacts the ability for different oceanographic systems to interact in the way they usually would, stops organisms from moving. Marine renewable energy has been shown to have a very minimal environmental impact, and this comes from modeling, lab studies, and then monitoring of actual devices that have been deployed. Finally, with most of the global population and most of BC's for that matter living near the coast, marine energy provides the benefit of producing power close to highly populated areas, and it's a massive untapped market for energy production. That being said, marine energy isn't perfect. There's still several significant challenges facing the development of these technologies, and costs are a huge one for wave and tidal. In comparison to offshore wind, it's one of the cheapest forms of energy available in the world. So tied into that is the establishment of supply chains and convergence on optimal device designs. So these are works in progress, as was shown earlier with the range of different types of devices being developed. Survivability is another really big one. So there's a ton of energy available in the ocean, but for anybody who's been out on it in a boat or swimming or surfing, it's extremely powerful. So this exerts really huge loads on these devices. And then you also have to contend with other issues such as corrosion and biofouling. Added on to that is the issue of having to deal with weather and appropriate weather windows and slack tide windows to actually go out and deploy or maintain a lot of these devices. And then finally, there are also issues related to the regulation of marine renewable energies and the need to balance development with different uses of marine space, whether it be fishing, recreation, or cultural uses. And then uncertainties about the cumulative impacts when we start scaling up the deployment of devices to larger arrays. So we're talking, tens to hundreds of devices. All right, now circling back around to Xaadáa, because that's why everybody's here. So our research program is focused on identifying renewable options that can contribute to the goal of 0% diesel use on Xaadáa. And we focused in on the most abundant and untapped resources that kind of have limited existing research around them. And so this research will increase the understanding of marine energy, while also highlighting the role it could play in supplying electricity on the island. And we hope that it could potentially support the development of sustainable projects in the near future. So in undertaking this research, Primed is very grateful for the research permit granted by the Council of the Haida Nation, and then especially for the technical support provided by the Marine Planning Program team, specifically Julian and Stu. And then the research has three components. So the first one is really to quantify how much energy is available around Xaadáa. The second is to start looking at where suitable sites are. So where could a potential project be located? How large could it be? And then finally, examining the benefits of how much electricity these projects could actually provide. So before we even begin considering marine energies, we first need to know how much energy is available and the distribution of these resources across both space and time. So this is achieved by deploying instruments. You see a few of them pictured here that Jackie will touch on in a little bit, that are used to collect data that can then be fed into and calibrate and validate resource models, such as the wave and tidal models shown here. And you may recall one of Jackie's first slides talking about the global theoretical resource. So that represents the total energy that's actually available in the environment, but there's several limits to actually harnessing the theoretical resource. And therefore it's not really representative of how much electricity you could actually generate. So for that, we need to start identifying the technical resource, and this is where constraints are integrated to further reduce the area in which power could be produced. These constraints include thresholds for a device to generate electricity. So for instance, that could be minimum current speeds to get a turbine in motion, or depth constraints. If it's too shallow, a device might not operate effectively. If it's too deep, anchoring might not be feasible or cost effective. And then finally, what we really want to get down to is narrowing down to potential sites and the practical resource. So this is ensuring that a site would minimize impacts on existing tenures, marine plans, avoid ecologically sensitive areas, and then uses such as fishing, and align with cultural values and a host of other considerations. Finally, the grid integration piece of the research program really allows us to answer questions related to diesel displacement. So for each project, how much do they cost? What is the optimal mix of projects to meet electricity demand? In its simplest form, one of the research engineers on the team, Anthony, runs a simulation, and this looks at how much electricity is needed in each hour based on historical demand data, and then calculates the electricity that could be produced by each project. So this includes existing diesel generators, battery storage, even the hydroelectric facility down on the south grid to meet that demand. And to maximize the benefit of our research, we're considering projects beyond just marine renewables. So we've examined those projects that have been detailed in the 2020 Gwaay Clean Energy Plan, in addition to considering scenarios where the two grids are connected, so allowing for a transfer of electricity between them, and therefore expanding the resources that could be considered. Once this has been completed, which we'll have a final report once our data collection is done in about a year or two, a final report summarizing these results will be submitted to the CHN, TYE, and BC Hydro to help support the planning of future projects. So the overarching benefit of this research is that it provides the people of Haida Gwaii with the necessary understanding of marine energy and other energy sources to make informed decisions about whether or not to pursue projects. It will also provide an assessment of the benefits and challenges in developing marine renewable energy, while also supporting projects such as the Yorebrook project. And just a thank you to the Yorebrook team who actually shared some of their tidal data with Primed, and that was used to validate the model for Masset Inlet that was illustrated a few slides ago. I'll pass it over to Jackie.
Yeah, so as Riley said, one of our first pillars is we need to characterize the resource, and we do that through our field work. So this slide just shows you an overview of all the different field projects that we have done on Haida Gwaii and some that we are hoping to do in the upcoming year or so. There's a bunch of different instruments on here. We're briefly going to go through them, tell you what they do, how they take their measurements, just in the next couple of slides. And so each of our sites that we have selected, we've selected them in collaboration with the Council of the Haida Nations Marine Planning Program, just to ensure that there's suitability for the community and as well for integrating into the electrical grid. So our first instrument we're going to talk about is called the ADCP. Stands for an acoustic Doppler current profiler, quite the mouthful. This device allows us to measure tides and tidal currents, and it works well without getting too technical. It does this by measuring the return of sound waves from the ADCP once they're reflected off suspended particles or phytoplankton that are traveling in the water column above or below it. And I say above or below because it can either be mounted on the bottom of the seafloor, looking up, taking measurements, or if we have it in a buoy, then it can be mounted in the buoy, looking downwards. And the frame of the ADCP houses a battery canister, and our batteries usually last for about 3 months with our sampling frequency, which is quite high, and so we get quite detailed data, high resolution data. We've done 2 ADCP deployments on Gwaay. So the first, and this is our first ever deployment, was in March of 2022. This was done in the Masset Inlet. And on that same trip, we were accompanied by a company called Lunacy, who is a company back east who specializes in oceanographic data collection. Their ADCP was only deployed for about 72 hours, whereas ours was deployed for the 3 months, the full time that battery allows for. I actually have another, if you go back once more, Riley, sorry. Our second deployment that we had was in Skidegate Inlet. So when we came back to Masset to collect that first ADCP, we did a second ADCP deployment in Skidegate Inlet. And that one was deployed for 3 months as well. We came back to recover that in September of 2022, which then at that point we deployed this tri-axis buoy. So our tri-axis buoy comes from a local manufacturer in Victoria. It's about 1 meter in diameter. It's a sphere that weighs about 400 pounds. And it's held down by a 1,600 pound or 1,200 pound anchor, sorry. And it's powered by solar. So this buoy allows us to measure wave properties, so wave height, wave period, wave direction. And what's really great about this is we're able to view the data live, whether that is it's in cellular network and we can view it that way, or if it's not, then we can access the data through satellite. And so, as I mentioned, in September of 2022, when we collected that second ADCP, we deployed this tri-axis buoy in Hecate Strait. So it's about 25 kilometers southeast of Sandspit. And it was deployed for a total of 9 months. And Riley and I actually just recovered this back in June of 2023. Our last buoy in our fleet is called the FLIDAR, which stands for Floating Light Detection and Ranging, or Floating LiDAR. And being the biggest, it stands 9 meters tall, 6 meters long, and 3 meters wide. And it is powered by a combination of things. So our buoy has 3 solar panels on board, 2 wind turbines, and then when solar and wind aren't able enough to power it, then there is a diesel generator on board that will kick in. Normally, we don't actually use too much diesel, which is awesome because the solar and wind have been quite good. And so when it comes to measurements, this buoy is our one-stop shop. It really can do it all. So it can measure wave height, wave period, and wave direction. But on top of that, it has the ADCP on board. So it can measure tidal. It also can do solar, air temperature, atmospheric pressure, humidity, and it has a LiDAR unit on board, which measures wind. We have yet to deploy a FLIDAR unit on Gwaay, which we are hoping to actually do come spring of 2024. And the proposed location is going to be northeast of Old Masset. And this is just based off data gaps and feasibility of a potential hypothetical project. And it made the most sense to look into the north coast, as there's a significant wave and wind resource over there, and along with the proximity to grid and suitable depths. So we looked at other options. So we looked at the west coast, but we thought because the depths drop off quite quickly, it would be difficult to go there, and there's a greater distance for transmission back to the grid. And then the Council of the Haida Nation has access to data on the east coast. So we wanted to identify a location that would be feasible and then build up resource understanding. But please note that the site that we are proposing isn't a proposed project, but it's just a site for us to start collecting data. With all this offshore wind, though, the question got raised, what about onshore wind?
Yeah, so switching to onshore wind, here's an example of a modeling piece that the team has already completed. So this was run last year. And the rationale was to examine if onshore wind as a next stage project made more sense than expanding solar further on the North Grid. So this was informed by a review of previously proposed projects, and then discussions with TYE. So we modeled 3 different scenarios. The business as usual includes the soon-to-be operational Solar North and battery project that Sean discussed, and then of course the diesel generators. The second looks at building out or doubling the capacity of Solar North, and then finally adding 5.6 megawatts of wind to the second scenario, and this is just 2 turbines. So when we were undertaking this work, we had a great idea, like Sean was showing with Google Maps now, where the solar and diesel are located. But we didn't know which locations had been considered or proposed for onshore wind. The Clean Energy Plan referenced a location around 4 kilometers south of Bassett. So we selected the site roughly matching that description we'd kind of heard referred to as Telephone Hill. So initial modeling, and this is kind of with low resolution data that's available online, shows that onshore wind is a clear winner. So it's able to meet over 60% of the annual electricity demand on the North Grid. It also provides 3 times as much power or energy, compared to solar on an annual basis per installed megawatt, while also being about half as expensive per megawatt. The caveat, though, on those prices is that the solar costs are more accurate as it comes from a project that's actually been built and has been funded, whereas the wind costs come from a 2018 proposal and have just been adjusted for inflation. So based on these really promising results and further interest from TYE, Primed expanded our research program to include an onshore wind assessment in an effort to provide maximum benefit to Haida Gwai's energy transition through our research.
So expanding that research involved us acquiring a LiDAR unit, which this is actually the same device that we have on our FLIDAR buoy, but instead of using it offshore, we're going to use it onshore. What is really great about this, it allows us to compare the benefits and the challenges of onshore wind and offshore wind, as the data will be collected in tandem. So how does this little guy work? Well, the LiDAR emits a beam that scans about a cone of 60 degrees. So as wind passes through each specified height in the air column above the unit, 50 wind measurement points are taken as that beam, or from that beam, and that's per second. So there's 2 ways to view the data. That's either that high resolution 50 points per second, or you can use it by averaging that data over 10 minutes. And it can also be used that way, which is actually the more common way to look at it. So the image on the left there just gives you a little visual on how it works. So there's that 60-degree cone that you see. And on the left side of that image, there's all the different heights that the LiDAR unit is taking measurements at. And so as the wind passes through there, those 50 points per second measurements are taken. So deploying this instrument offshore is a little bit easier than deploying it onshore, and that's because offshore there's no neighboring buildings obstructing the LiDAR beam or nearby objects that may cause turbulence. So when we are deploying it onshore, there's a few things that we do need to take into consideration. The first being that it does require a 3-phase AC/DC power supply. This can also be acquired through a battery pack, but it's a little bit less reliable and it's a bit more complicated than just plugging it into the grid. And it is a little bit different than the setup we have on our buoy. And so it would require a bit more engineering and design work on that front. The second thing that we want to look at for site requirement is that the LiDAR scan is free of any obstruction. So like I mentioned just a couple seconds ago, that it does have a beam that scans a cone of 60 degrees. So if there's any neighboring buildings or overlying tree canopies, that'll get caught by that beam and then give rise to inaccurate wind measurements. Or if those buildings are too close, it could cause wind turbulence, which also will give you a little disruption in your data. The last site requirement that we need is there's 2 MET stations on the LiDAR unit. So there's one attached. You can see this in the image to the left. There's one that's actually attached to the LiDAR unit. And then there's a green arrow pointing to one that is remote. And both of those MET stations need to have a clear airflow path to be able to collect measurements accurately.
So yeah, it's still not clear where this data collection should take place. And here you can see the location that Primed used for that initial modeling, along with a few other sites that were referenced in existing energy planning documents. But for instance, a project located out at Rose Spit likely doesn't make sense for environmental and cultural reasons. And then you also have to factor in the high costs associated with actually trying to build out transmission lines to get it towards existing infrastructure. And then for the airport, I'm not involved in aeronautics too much, but I don't think wind turbines and airplanes go all too well together. So that's probably not a good choice either. And then the 2020 Clean Energy Plan isn't explicit in the location they reference. And the 2008 Clean Energy Plan actually references a location that was just a few kilometers from the site we had chosen. So this year-long deployment of the LiDAR would be best suited in a location that could be the site of a potential project. To determine that, we need to look at technical and economic feasibility considerations, mitigation of environmental impacts, and then community approval. So we think that the Telephone Hill location is suitable for data collection based on its proximity to those existing proposals, the availability of power likely at the site, the area has already been cleared, and it's easily accessible. So we would still need to do some ground confirmation of site suitability and approvals to use the area, as well as community input, which we're hoping to get some feedback on tonight. So for instance, one environmental concern, if you actually built out 1 or 2 turbines here, is the proximity to Katla Slough and the range of resident and migratory birds that use the area. So again, Primed is not proposing a project at this site. This LiDAR is strictly meant to collect baseline data that can then provide a more robust assessment. So actually feeding in data that's been collected on Haida Gwaii to the energy modeling to provide a robust assessment of the benefits of an onshore wind project. And we're eager to hear if there might be better suited locations or other ideas for where this device should be deployed. So with that being said, thank you. And I guess we can open it up to any questions.
Hello, Riley and Jackie. So yes, if anyone has any questions on what UVic Primed is doing or Yahda, feel free to put in the chat, or I can, if you raise your hand, I can let you unmute. Just let me know. But we do have some questions for the community. So we heard from Riley, where would be the best location for data collection? Would it be Telephone Hill? Is there a better suited location?
Hello.
Go ahead, JP.
Hi. Yeah, I'm just we've been watching. Thank you very much for the presentation.
We're in Whitehorse.
Yeah, we're in Whitehorse. we come to Haida Gwaii fairly regularly, except the last few years. But we do have a report that we created for. I was subcontracted by another firm to assess the wind potential on Haida Gwaii for the village of Queen Charlotte City. It's not called that anymore. I'm sorry, I forgot what the actual name is now. And I believe it might still be on their website. But this report basically, I had looked at the wind potential right across Haida Gwaii, and my expertise. I apologize. I should tell you who I am. My name is JP Pinard. I'm based here in Whitehorse. My wife and I are in business. We have a company called Wind Heat North, and I've been assessing the wind potential right across the Canadian Arctic, particularly the Yukon. But I was just in Nunavut actually to install some meteorological towers, not LiDAR, but I one day probably will be installing those. In the Haida Gwaii, so we were commissioned. I was commissioned to look at the wind potential, for another contractor. And basically what I found that the best wins were basically on in terms of location to a power line. And I looked at both the North Grid and the South Grid, and what I came upon is the location is on Mount Pool near Sandspit. Primarily why we chose that site, because there's forestry roads up there, and there's a power line to a hydro site going through that hill. So just letting you know, this is a study we've done, and you could probably, I would suggest actually putting a LiDAR there at Mount Pool would be perfect. That would be a good place to start the measurement campaign. I'll stop at that. Thank you. Thanks for hearing me.
How was so much for that, JP. I'm going to jump in just briefly to say hello. It's nice to see you here. I went to the Village of Taajuuwee's website and I can't find that report. So maybe if you can pass it over to me, then I can make sure that I share it with the primed team. That would be really helpful. Yeah, I think that would be a great follow-up if you're able to share it. And then there's a bunch of questions in the chat there as well. I'll just name a couple of them so that the primed team can help provide some answers. How soon could a project potentially be connected to the grid? What about the military zone near the elephant cage? I'm going to trust that Jackie and Riley, you know what the elephant cage is.
We do.
And wondering how amenable BC Hydro is to connecting tidal to the grid along Masset Inlet.
Yeah, so for the first question, how quickly could a project get up and running? That's kind of outside our purview. We'd be collecting data for at least a year. There's a lot of work that can go in to actually looking at technical and economic feasibility. Maybe Sean can talk to like the project conceptualization for solar and what kind of process that would look like.
Yeah, for sure. Well, for our solar project, it's been in the works for a number of years, right? Like the concept started as a different renewable energy project that ended up turning into the solar project. And so the feasibility was done in 2019, actually, for the solar project. COVID happened and a lot of different delays there. So, it's been in the works for about 4 years now, and it will be done next year. So all in all, through COVID, even like it has caused a lot of delays, but I don't expect Solar South to take 5 years. That's for sure. I'm really thinking that one's going to be done within about 18 months from start to finish, like including feasibility, everything else like that. With this wind project, I'm thinking it's probably going to take about 5 years as well. The data collection, we're going to have to take that feasibility and start to make a business case out of it, acquire funding, and then start to build construction and that sort of thing. So all in all, with the solar project, it really was breaking a lot of different ground with BC Hydro, really showing that we're serious about getting off of diesel and Gwaay, and that we can implement major projects here. With the wind, I can sort of foresee it being similar to that, where it's another major project that hasn't really been done before, and we're really just sort of breaking that ground to show that we are serious about getting off of diesel again, and taking that next step to bringing wind into the mix. And of course, this is all dependent on a lot of different factors, right? So with everything going like really smoothly, maybe it can be done within 4 years or something like that. But my vision is to have it implemented and up and running by 2030.
Awesome. Circling back to the tidal question. So I'd say BC Hydro is much more favorable in their outlook on tidal than they previously have been. So I've been a part of a few meetings with TYE and other energy planners on Haida Gwaii a few years ago, and BC Hydro directly referenced tidal as being an option that would be considered now. And if you look at the global outlook of it, there's been facilities that have been operating and providing power to the grid for over 3 years. And that's one of the main considerations for BC Hydro to start looking at integrating new technologies. So you have to have 3 examples of projects operating for at least 3 years and providing reliable power. So Tidal has met those metrics. It is commercially viable, especially in places like Scotland. So I think they would be open to a project if Taajuuwée and the people of Gwaay decided to pursue one.
Just to note, currently we are supporting the UVic energy project as a demonstration project. And Clyde and the team's real vision there is for us to partner with them eventually. We haven't gotten there yet just because we are really focused on the solar farm, but we are considering Tidal as part of the energy system of Taajuuwée.
And then
Not that we were planning on implementing it like right away or anything like that. We are just looking at like what it's going to take to get that there, though, and supporting this UVic energy project in any capacity we can. Sorry, go ahead.
No, it's all good. And then speaking to the military zone location near Elephant Cage, and correct me if I'm wrong, Riley, but I believe we have looked into it, and I think the regulations around that, especially just being in the military zone, is a little bit complicated, to say the least. So yes, we have considered it and have slightly ruled it.
Maybe another question for the community: what local values need to be protected in proposing this or any wind monitoring location? What do we want to ensure is being protected? So yeah, I know you brought up bird migration routes. Yeah, I know one of the identified considerations for wind energy is building local small wind projects. And so maybe that's another option.
Yeah, and I think if you look at the electrical system on Gwaay, so for instance, 2 turbines to meet around 60% of the annual electricity demand on the North Grid, you're not looking at building out, a 20 turbine array. So obviously the more turbines you have, the greater the risk of actually having a bird strike. It certainly is a risk, and bird strikes do happen. So there's always going to be trade-offs between different energy types, but I would say for 1 to 2 turbines, even a few more, that risk is pretty low. That's not guaranteeing that there won't be bird strikes. You likely would end up having that over a 20 to 25 period of time when a project would be operational.
That being said, part of the selection criteria for the solar farm too, and with this wind one as well, we weren't looking to disturb or clear any area that wasn't already like cleared or disturbed. So that was one of the reasons why we went with the Masset Airport. And again, like this is something that we're looking at here in that, if we can use an area that's already like an old cut block or something like that, or in an area that's just naturally doesn't have a whole lot of like disturbance or interference, and that's sort of like ideal.
And maybe back to you guys, how will the community stay involved as research unfolds and possible future projects are proposed? How do you want to keep the community involved?
Yeah, from Prime's perspective, I think this is a really great opportunity. So we've been up, I think, on 4 trips now. Always trying to, if people ask what we're doing, because some of these buoys look pretty weird, like they look like spaceships or something driving on the back of a pickup truck, making sure we're staying friendly and talking to anybody if they have questions. Webinars like this, we're always really keen to be involved in. We had a presence at the Swiilawiid Energy Symposium last spring. and we'll look to do some further engagement next spring as well. Also looking to maybe present at the high school and just share some broader energy knowledge with anybody who's willing to listen. And then you can always drop an email to Jackie or myself or on the Primed website. Get in touch if you have any concerns. We're always happy to chat with anybody as well.
And Sean, how about Taajuuwée, keeping the community informed? I know you mentioned about, I saw on your PowerPoint, the January 31st and February 1st dates.
Yeah, so we do have some upcoming community engagement. We're looking at doing it, as you mentioned, January 31st and February 1st. Those are going to be the first open houses that we got for the new year. We're going to be talking about the community energy plan, showcasing some of the demand side management initiatives that we have so far with Old Masted and Skidegate. And then talking to people about what types of renewable energy modeling and sort of just comparing stuff that we could be using sort of or on Xaadáa, sorry. Yeah. So yeah, take a look or keep your eye out for some open houses next year.
And yeah, there was also, Aline just dropped in the chat the UVic Primed website. And then I also put in a website we created that details all the fieldwork. So we had this up and running at the same time as the Swiilawiid Energy Symposium. And it's really great to visualize all these different sites and what some of the data collection devices look like. And at the end, there's our email as well if anybody wants to get in touch.
I'm not sure if you're able to answer it, but we did have an emailed question asking, is solid state wind energy on the table?
I'm sorry, what was it?
Is solid state wind energy on the table? That was an emailed question I got.
I'm not sure what that is, so not at this time. Although I'm always open to like hearing about new technologies for sure.
Does anyone else within the webinar have any questions?
Hi, Sally, just reminding me, are you, when you're looking at the modeling for wind or your renewable resources for your, is it just electricity demand, or are you looking at heat load and transportation as well?
Yeah, so it's not any transient modeling, so we're not actually looking at voltage stability. The model's not that refined. It's just energy. So you have a demand profile. We chose 2017 as it's a year with pretty complete data, and it matches really well the load forecast within the clean energy plan. So for each hour or time step, you're just meeting that demand with the different resource and technology models that you're inputting to it. So Anthony's model basically dispatches renewable energy first. If there's excess energy, that's curtailed and sent to battery storage. And then if you're still not able to meet that peak load, that's where the diesel generators come in to meet that load. So always trying to optimize to minimize diesel use. But it's not like extremely detailed modeling that like TYE and BC Hydro would be doing for actual voltage and grid stability when you look at actually building out a project. But it's a very low cost way to look at the effectiveness or the optimal mix of different projects when you're kind of looking at a high level and trying to screen through a bunch of different projects.
As far as that modeling's gone, we haven't really looked at what the transportation and heating load has been of our diesel use. We know that it's up there, and that we are I mean, it sounds so political, but we are working on it with the DSM initiatives that we have going on with both Old Masset and Skidegate. But that was a huge part of that too, was you know, a recognition that a lot of the heat that was being used was from diesel furnaces, and in the last 5 years that they have replaced both in Skidegate and Masset. I think the total is around 650 heat pumps from old oil furnaces. So there's been a real big conversion from oil heat to electric. But that being said, it's still diesel electricity, right? So that's another part of what we're trying to solve here.
Maybe one last round if anyone has any questions or anything before we wrap up. Not hearing anything. All right, well, how was so much, Riley, Jackie, and Sean? It was great to hear updates on. Oh, do you have anything? Sorry. Oh, you have some more questions. So would it take 5 years to connect all of Haida Gwaii? I'm assuming to renewable energy.
I'll leave that to Sean.
Thanks. Yeah, that's a tough question. I guess if we have enough capacity and people interested in like a lot of real big push, then we definitely can do it in the next 5 years. But I really, right now, that's kind of ambitious. I do think that we're going to have a very big impact on the amount of diesel that we're using right now. But I don't think that we're going to make it to 100% off of diesel by then. It depends on really what happens between now and then, as far as tidal being proven energy, whether or not we can connect the two grids together between Masset and the north and south grids, and what that sort of looks like in between the two when they're connected, if that's going to be another battery or what. And then what types of renewable energies that we're allowed to pursue, well, and sort of like ambitious about taking seriously. So yeah, anything's possible, really, right? It just depends on how much like passion and ambition that a lot of people want to contribute, and what sort of level that, you know, a lot of what we have going on is based on grant funding, but that isn't to say that we can't like do it on our own after this one as well, right? So just showcasing that we can really make these major projects happen is a huge step, and something that a lot of us are really proud of, actually. And it really shows that we are getting towards that 100% off of diesel goal that we were all like have in our vision, right? So it is possible to make it happen in 5 years, but I'm really thinking that you know, for that to happen, we're really going to need some ambition and some good passionate players at the table for sure. So if you know some up and comers, then let's start working with them for sure.
All right, Hawa, Sean, and Hawa, for you all for joining us, and Hawa again, Riley, Jackie, and Sean for presenting. This is only our one out of our 2 fall webinars. Feel free to join us next Wednesday, November 29th, for Cooperatives 101 with Haida Gwaii Renewable Energy Cooperative, BC Co-op Association, and Peace Energy Cooperative. I will be on Zoom again. So Hawa for joining us again, and have a good evening.
Thanks, everyone.
Thank you, everyone.
What?